So we are now going to go on to 7.3.4 and talk about slope fields. We're going to split up this lesson into 2 days. Before we start, I want you to print out the resource page that I attached to this, the lesson 7.3.4 resource page. We are going to use that to try and represent our differential equations as graphs to get a visual representation of what our antiderivatives are. So it says here that Teresa, who doesn't know how to integrate, so she doesn't know what this is studying the differential equation. The derivative of something equals x. Well, we can work backwards and we could say, well, what is the function that when you take the derivative of something, you get x? So that's what she's going to try and figure out through talking about slopes. She knows that this differential equation represents the slope of tangent lines of a function. She wonders why y equals f of x looks like that, what it looks like on the graph. So she starts to sketch tiny tangent lines for x equals 2. She's very careful to draw them with the correct slope. Let's examine her sketch. So why do all of the tangent lines have the same slope at x equals 2? So why is this the case? So why are all of these going to be the same? Well, at 2, someone says dy dx. When x is at 2, that means our slope is 2. So when we're at 2, we have a slope of 2. Well, what is the slope at 3? It'll be 3. What's the slope at 4? It'll be 4. What's the slope at 1? 1. What's the slope at 0? -1, -2, -3. -4. So what does it look like if we were to draw all of these slopes when x is each of these variables? So I'll go ahead and draw that right here. We have, I'm going to include 0 as well, and then we're going to do above. Now we need to be kind of careful when we're drawing these, otherwise it's not going to look like what we want it to look like. So when x is 1, we have a slope of 1. So that means we want to try and draw slopes of 1. When x is 0, our slope is 0. When x is -1, we have a slope of -1. When x is -2, we have a slope of -2. -3. Notice what's happening is we are getting steeper as we go along our graph. I'll go ahead and do the other ones over here. What did I use? Red. I'm trying to maintain a consistent color here for each of these so that we can notice a pattern. It'll be helpful when we do the next set of problems. So what we just drew here is our first slope field. As you can see, there's probably some graphs that we can draw that represent some graph, many different graphs actually. So we drew the tangent lines. This type of graph is called a slope field. Teresa starts jumping with joy. My slope field represents that the antiderivative of x is equal to 1/2 x squared plus c. Let's go ahead and use differentiation to show how she knows this. So we'll write dy dx equals x. We're going to go ahead and move the dx on the other side. So dy equals x dx. We're going to take the integral of 1, the integral of x. The antiderivative of 1 is y, and then the antiderivative of x is going to be x squared, but we need to put a 1/2 there because when we take the derivative, 2 times 1/2 equals 1, plus c. So you probably see the shape of a parabola in this. In fact, there's many parabolas, and that's why there's a plus c there. Teresa's ecstatic because there are so many solutions to the differential equation. What does she mean by solutions? How many are there? Well, there's an infinite amount of them. She wonders about the solution that goes through her favorite point. You guys all have favorite points, right? -3, 1 is her favorite point. So let's go ahead and find how many solutions would go through that point. So -3, 1. -3, 1. Okay, and we're going to figure out, so we're going to have some graph that looks maybe something like that. That'll be my sketch. But it's really only going to go through, that's just our one solution. And that's what would happen if we were to plug in -3, 1, and we solve for c. So we're going to end up getting this one graph right here. And we should get a c of something like negative something. It doesn't matter. So the next problem we are going to do is going to be these three other slope fields, or these three other graphs. So in the resource page, we're going to fill out this table here, and we're going to plug in each of these numbers. So notice that this one's a little bit weird because it's not x, right? It's in terms of y. So let's go ahead and plug in -4. -4 times -2 is +8. -3 times -2 is +6. 4, 2, we have 0, -2, -4, and -6, and -8. And now what we're going to do is we're going to draw each of these slopes. Now these slopes are a little bit weird because now instead of us going by x's and drawing down lines along like this, we have to go by y's. So we're going to end up drawing lines across instead. So we're going to do the, when y is 0, so that's going to be our heights, we have all of these slopes are going to be 0. So let's draw all of those slopes to be 0. Then when y is 1, we have a slope of -2. So when y is 1, we have a slope of -2. So we're going to go something like, I'm going to do a different color here so we can show. Oh, yeah. Sometimes I can't change colors. It's so annoying. Okay. So we're going to do a slope of -2. And all of these are going to have a slope of -2. And then when we are at a height of 2, we're going to have a slope of -4, so that's going to be even steeper. And then we're going to have a slope of -6, which is even steeper. And then we're going to have a slope of -8, which is even steeper than that. Come back. Whatever, we'll do orange. So as we increase in y's, we end up getting steeper. Let's see what happens if we go at negative y's. So negative y's, we end up having a positive slope of 2. I'm going to do green here. We have a positive slope of 2, so that probably looks something like this. And we have a slope of 4, so that's a little bit steeper. Drawing slopes of 4 and slopes of 8 and or 6, and just like, how do you make it look steeper each time? It doesn't need to be incredibly accurate. All right, so that one's a little bit of a weird slope field. Let's compare to the next one here for B. Now we have an x and a y, and this part we don't have a table, so this could be kind of confusing, but let's just think about, we're going to have to think about each point, and this could get kind of annoying to do, but if we said, let's say if x was 0 and y was 0, well 0 plus 0 is 0, so we're going to have a slope of 0. Where would we have a slope of 0? So if x was 1, y could be -1, and we'd have a slope of 0. If x was 2, y could be -2, and we'd have a slope of 0. Same with -3, -4, and 4. If x was -1 and y was 1, we could have a slope of 0. So we're going to think about all of those are going to have a slope of 0. And we need to do this at every point, and every point is going to be kind of annoying here. But if we notice the pattern, we can do a lot of points all at the same time. So when these are all going to be slopes of 0, so when do we have a slope of 1? Well, when one of the numbers is 1 and then the other is going to be 1, is going to be -1 less. So or 0. So if x was 0, then y, or if x was 1, then y could be 0. So x is 1 is y is 0. We'll have a slope of 1. So where else would that happen? Well, if y was 1 and x was 0, we'd also have a slope of 1. If x was 2, y would need to be negative 1. If x was 3, y would need to be negative 2. If x was 4, y would need to be negative 3. If x was negative 1, y could be 2. If x was negative 2, y could be 3, so on and so forth. What if we had a slope of 2? So then if they were both 1, 1, we'd have a slope of 2. So we'd have a slope of 2. If x was 2, y could be 0. If x was 0, y could be 2. And, oh look, we could just go along this diagonal. So what about a slope of 3? And we could do, if x was 1, y was 2, we'd have a slope of 3. If x was 2, y could be 1, we'd have a slope of 3. If x was 3 and y could be 0, we'd have a slope of 3. And if x was 0, we'd have, okay, so we'll just do all of these. And then how about a slope of 4? So that could be this one. And then how about a slope of 5? I need to do a different color. And as we go up in this diagonal, it just gets steeper and steeper, right? So then let's go ahead and do the other side, see what happens here. So what happens if x was negative 1 and y was 0? Then our slope would be negative 1. What if it was x was 0 and y was negative 1? We'd also have a slope of negative 1. And so on and so forth for all of these. Then how would we get a negative 2? Well, if negative 1 on them both, that'd be a slope of negative 2. If x was 0, y could be negative 2, and then we could have a slope of negative 2. And if x was negative 2, then y could be 0, we'd have a negative 2, and so on and so forth. And you'll probably extrapolate that the same thing would happen, except in the opposite direction. All of these would get steeper along this diagonal. We're going to use red next. Okay, purple. We're going to talk about what these slope fields are going to make later on, since we're finishing this lesson in 2 days. But I want to go on to the last problem. Actually, I want to see if I have enough time for the last problem here. Where's my timer? 12 minutes. And I don't really have enough time for the last one. So what we're going to do is I'm going to have you try and do C yourself. Let me know if you have questions using the other ones as a guide. And then your assignment is going to be problem 83. Just 83, and you're just going to draw the slope field and do problem B. If you did C, why don't you go ahead and pause it right now, do C, and I'm going to show you the answer for C, so that we'll have a reference. So here we go. Going back to C, that is what C should look like. A little bit weird, I know. Okay, I will see you guys later today.